So it's 2 p.m., you're after lunch, and I have to talk about security. So it's a terrific recipe for a successful talk. And my name is Ory Segal. I'm the co-founder at PureSec. I've been a part of the application security scene, if you can call it that, for the past 20 years. Started back in the end of the 90s with a small company called Sanctum. How many of you heard about Sanctum or AppScan? Was the world's first web application firewall? Yeah, an old product there. I was responsible for the research of some industry-leading application security products, IBM AppScan, AppShield, and recently Akamai Kona Site Defender. I'm also the author of about 20 patents in the field of static analysis, dynamic analysis, interactive application security testing. I'm also a WASC officer, Web Application Security Consortium, contributor to OWASP, NIST, and so forth. And that's my Twitter. So I'm going to talk about the paradigm shift required when talking about application security. I'll talk about a little bit about why the existing security solutions that you currently use, like web application firewalls, are irrelevant for serverless. We'll talk a little bit about what are we up against, but there is a very thorough and concise document called the Serverless Security Top 10 that I'll get back to in a second that you should read. And we'll see, well, it's not really a live attack, but I will attack a serverless function, and you will see some visualization. I'm not here to push or to pitch any kind of product whatsoever. PureSec is over there. So, talking about application security in general, or about serverless security, you have to remember that we are talking about application layer security, only the stuff related to the code that you're deploying. The rest, everything under your functions is handled by the FAS or the cloud provider. Anything from the regions, the locks, the guards, the security, combination on the locks to the server, stacks. Everything like that is handled by, where is Boaz again? By, the vendors. When I'm talking here about application security, I'm talking about, the security of the logic, the code, the functions, the cloud services that you consume, their configuration, the roles, the permissions, and so forth. So that blue part is what we're going to talk about in the next 16 minutes and 43 seconds. So here's something that I'm going to try to establish. Your serverless functions, if you own serverless functions, are probably the least secure, link in the cloud environment that you have. And if you look at your current security posture, when you add serverless, this is what you end up with. It's a joke, but I'll establish that in a second. And just quickly, getting that off the table, what are the serverless attack vectors? So this is a very, rudimentary, maybe even naive schematic of how a serverless function work. You have an event triggers the code, the function, which does some operation, calculation, transformations, and then maybe interacts with some cloud services, S3 buckets, blob databases. I don't want to, insult anyone. And then it generates some output, hopefully. So what or where can an attacker actually influence the serverless function? So we start with the event data, HTTP traffic that invokes the function, database changes, Kinesis streams that Boaz just mentioned, SMS messages, emails, anything that can trigger a function can be used as a vector to actually influence the function's execution and is therefore a threat. Next, the code that is being used. That could be a third-party component that your function is using. It could be that somebody managed to get access to your code and modify the code. That's another vector in. And last but not least, an attacker can compromise one of those third-party or additional components or resources that your function uses. So for example, a compromised S3 bucket or a compromised remote API that you're doing a RESTful call to. And what can an attacker gain from this? Obviously, anything an application layer attack usually does. Injection of code, bypass of authentication, compromising data, leaking sensitive data, manipulating the business logic, denial of service, God forbid, and so forth. So why do I claim that you can't really use existing security solutions? Hey, you've got a WAF, probably you're paying a lot of money for that, right? Why can't I use my WAF to protect against application layer attacks for serverless? And I'll show a nice diagram of this in a second, but you have to remember that traditional application security solution, they rely on the fact that you have to deploy them somewhere. They protect the application by being deployed and inspecting the network traffic or the servers on which they are deployed. If you take a look at a WAF needs to inspect layer 7 traffic, right, to detect attacks. A web application firewall. I apologize, I'm usually talking to a room full of application security geeks. So, sorry about that. If you're thinking about endpoint prevention, protection, IDS, IPS, all of these have to be installed either on a network or on some server. However, in serverless, that's not the case, right? You only own the functions code. That's all you get. That's like a double-edged sword, right? A lot of responsibility is taken away, we talked about that, but at the same time, you have no place to install any kind of security protections. So, one might claim, and one is me, that the traditional security solutions are now irrelevant or unsuitable. Let's take a quick look at how that happens. So you have your application, could be a cloud application, could be running on-prem inside a white thing. And then you want to protect it, right? So you use a firewall, like a checkpoint firewall or a Palo Alto to create a safe zone. And then you use IPS, IDS to make sure that nothing bad is happening in your network. And then you use EPP and other 3-letter acronyms to make sure that there's no malware doing malicious things behaviorally. And then you put a web security gateway to make sure that bad traffic is not going out. And also you put a web application firewall, a WAF, to make sure that nobody is manipulating your application layer. But what happens when you go serverless? So all of this goes away because you can't install these solutions, right? And your functions are basically left at the forefront of this new battle, if you will. And attackers can now access your functions directly. Authentication is not security, for that matter. It's not application layer security. I'm not going over all of this. You can get the slides, but this shows how WAFs and RASP, runtime application self-protection, is not really relevant for serverless. First of all, you can't deploy them. You can't deploy RASP. You need to install an agent to instrument the application. You can't install a WAF because you have no server and you don't control the network. They also don't inspect the right things. Think about a function that gets invoked by an event. There's no HTTP traffic going on. What if the invocation came from a database change on a DynamoDB table? How a WAF can help you there? Can it even parse the messages going between the Dynamo and the invoked function and so forth? So all of this becomes irrelevant. The only place that a WAF can probably help you is when your serverless function serves as the backend for a web app. In that case, a WAF might be able to inspect incoming traffic, maybe parse it and analyze if you're using MQTT, or if you're using like the IoT button that was presented here by Boaz, or if you're using complex JSON messages, your WAF is not going to be able to pull that off. With regards to RASP, it's very simple. You need to instrument the application, and since you don't own any of the underlying server, that becomes irrelevant. So back to what are the bad things that can happen and what are the most common weaknesses. Earlier this year, around January, we published together with this group of thought leaders this white paper called the Serverless Security Top 10 Most Common Weaknesses Guide 2018, and that's a mouthful. I urge you to download it. There's no way I can cover all of this. I'm actually only going to touch on one key element from the top 10, and it includes mitigation techniques for all the most popular platforms. So go ahead and read it, and even better, send it to your developers. So these are the top 10, and we are going to concentrate on SAS1, the function event data injection. That's the only thing I'm going to be able to show today. But rest assured, some of you probably know a lot of these from the OWASP top 10. However, some of these are completely new, and those that are old are they have a twist with regards to serverless. Obviously, things are a bit different. So without further ado, let's talk about event data injection, my personal favorite. So what is it? So you've all heard about SQL injection and cross-site scripting. Again, wrong crowd. That occurs when input coming from an untrusted source makes it all the way into your function, to the sensitive places that your function do. For example, if there's a database query going on and an attacker can influence the database query, that's the point where you have a SQL injection attack, and the attacker can actually manipulate that query. So your developer thought that he or she was doing something, they had a design in mind, and then somebody came in, sent some bad input, and caused that design to take a wrong turn at some point. So that's, in essence, what injection-based attacks are. In serverless, it's interesting because, for me, coming from the web app security world, there's only one kind of input, HTTP. It can either come through a parameter, a URL parameter, a post body parameter, or a header, a cookie for that matter. But that's pretty much it. All I have to do is inspect HTTP traffic. If I know how to do that, I'll be okay. In serverless, everything becomes a bit more amplified. So you have a lot of different event triggers. Boaz showed a few of those. You've got S3 buckets and blob storage on Azure, and HTTP, obviously, and MQTT for IoT devices, and database changes that can invoke and function. And each of these has its own format and sort of language. They all pretty much look the same, but they all have their own message format. And now you have to know how to analyze and understand if there is an attack in each different type of event, which is obviously what we refer to as an amplification of the attack surface. I only had one path in, now I have dozens of different ways. And obviously the other angle to this is that, as I said, traditional application security solutions like WAFs won't work for this. So you're pretty much with a problem here. So how does it look like? And I can't zoom because I'm not there. But this is an example of an actual SMS-based or SMS invoked serverless app that generates a report, a balance report for the user. And what happens here is that somebody's, I'm going to be here and block this. Somebody's taking the email, which is what you type in the SMS, and puts that or embeds that inside a shell command. Now, it sounds stupid, but I've seen much worse. And some of you are probably now thinking, I think I've done that actually before. And so that email is being used inside a shell command, which is probably the worst thing a developer can do, because now instead of sending an email like ory@puresec.io, I can send whatever I want, something like that. So that's an email as well, right? I added a semicolon, which allows me to send a secondary shell command in Unix. And then I just do whatever I want inside the container running the serverless function. So here I'm using curl, which is an HTTP request, to actually send the environment variables out to an attacker. Okay? Clear? A little bit. This is real, by the way. And so are the two examples that you're going to see now. These are taken from GitHub. So the first, and again, I'm sorry you can't see, those from the first row, anyone can figure out what kind of vulnerability lies here? So take out your phones. I have a QR code for that. I'm just kidding. No. So cross-site scripting, but close. So again, this is a function that sends an SMS message, the data coming from the user, and it just sends an HTTP response back saying like, okay, I sent the message, but then it echoes back the user input or the SMS message, which means that I can execute malicious commands. If I send you this URL, I can execute JavaScript with your browser permissions. I'm not going to go into what cross-site scripting is right now. The other example, even smaller in size, actually, let me do this. So who can guess what the vulnerability is once I move the mouse to the right? Anyone? No, that's not the one. Anyway. So there's a command injection here. Again, this is a function that backs up a Dynamo table. You send it an email with the name of the database, and it actually dumps the content of the database, backs it up into an S3 bucket. Very useful. You know, you sit at home watching TV and you remember that you didn't back up your database. You send an email with the name of the table. However, you can send shell commands here again, semicolon, whatever, this is sleep, and this will basically manipulate the serverless environment to execute malicious commands. You can, fetch data, whatever. So 3 different vectors, by the way, that we saw. We saw an SMS message as the vector going in. We saw a web request, and then we saw an email. Again, only the RESTful API part would be relevant for web application firewalls. So, how do you secure a serverless application? You're probably asking, I hope. Okay, so the first thing you want to do is you want to make sure that your functions are least privileged and hardened. And that means that your functions only have permissions to do what they need to. So if your function needs to read an object from a specific S3 bucket, you want to make sure that you don't give it read for the entire set of buckets that you own, or else someone will come there, exploit the function, and read your entire data from all of S3. And that's just an example. You need, and that's probably number one, you need to know when you're being attacked, and that's probably the first thing you want to do. You need to turn on the lights on application security for serverless, and right now you're pretty much in the dark. Think about it for a moment. Those of you that have serverless functions running now somewhere in the cloud, do you really know if you're being attacked? Do you have any kind of visibility tools, security visibility capability to know that you're being attacked? Can you do any kind of forensics now on a security event? So that's, again, one of the biggest problems. You need to block malicious event inputs that we've just seen. And obviously, you need to detect and prevent malicious behaviors. So what happens when your function usually does A, B, C, and today it's only doing A, B, C, D, E, F, G, shell command execution, right? That's a malicious behavior. So that's the kind of things that you need to be able to detect and block. And obviously, many people are talking about the security posture of serverless applications. It's something that you have to remember. Do you know, how bad the situation is or how good the situation is? Do you know how many functions do you have? Are they using the latest third-party components? Are they inspecting malicious input? Are they running the latest version of, whatever? So security posture visibility is also very important. And now I'll do a quick demo. However, again, this is vendor neutral, so I'm not showing any product. So I have a Lambda function. Again, we can do it as a drill because I have 1 minute. Anyone can spot the vulnerability here? When you do this DEFCON, it's much faster. OS command execution, right. So I'm going to send this Lambda a string, and it's going to echo it back, hopefully. That's all it does, by the way. It accesses a Dynamo table, and it sends the echo, the string back to the screen. However, as Shimon mentioned, you can inject malicious shell commands. So instead of a string, I'm going to put a semicolon and then call curl, which allows me to send an HTTP request to fetch some fake malware from Pastebin. Usually I have to explain what Pastebin is. I hope this is the right crowd not to do that. And so you can actually see it says hello from hacker, which is not what happened before. So what I want to show you now is what happens, or how it looks like. Can you all see the, okay, the text is a bit small, but you can see the bubbles, right? Good. So Lambda invoked my Python 2.7 runtime, or my function, which then sent a request in code to Dynamo and put an item there. And then it called bash in order to echo back my string, the string that I wrote hello from Lambda, right? The second execution looks completely different. So Lambda called Python that put something in a Dynamo table. That's all exactly the same. However, from here, you can see that bash ended up calling curl, which ended up connecting to a lot of IP addresses, one of which was pastebin and trying to fetch a URL. So when I'm referring to making sure that you are able to detect and understand malicious behaviors, these are the kinds of things that I'm talking about. Look how different the execution of the function look like. This is normal. And this is really, really bad. And that's the kind of visibility that you need to make sure that you have in order to be able to analyze and detect and mitigate and protect serverless functions from application security solutions, attacks. I'm out of time, so are there any questions? So the question was, why can't WAFs inspect traffic over HTTP like WebSockets or MQTT? It's just that WAFs are 5 or 10 years old technologies today, and they're driven by customer demand, and customers don't demand WebSockets and MQTT yet for WAFs. That's the only reason. There's no technical limitation, it's just not implemented, at least not the WAFs that I know, like the Impervas or Akamais or those guys. So the question was, you probably know how to detect and analyze malicious input, but how do you gain access to the underlying platform in order to detect malicious behaviors, right? Well, go to the PureSec booth, but that's the only pitch I'm giving today, okay? That's it. It's a good question. The question is, do we anticipate that vendors will provide this kind of protection? So they haven't done it in the past for any other thing, so you don't see hosting providers, take care of your application code and your security, or for that matter, AWS or the others. They do provide some tooling around, mostly around hardening. Because your code is your responsibility. At the end of the day, they can't enforce something. They don't want to restrict your developers from being successful. They want to give you the platform and the tools to build whatever you want, and if you need security, it's on you. That's your responsibility. And that's the shared responsibility model again. Okay, thank you.